Okay, hi everyone. So in this video, I'm going to try to explain and motivate how you can implement or how you can obtain the decrement repeater higher order function. And so this is a assignment question, and the answer is basically this highlighted part over here. But I'm not just only going to show you the answer. I'm also going to try to motivate how you can derive and arrive at this answer by yourself. Okay, so first we need to have an understanding of what the repeater functions do. But before that, let me just have a short side note about the display function. So if I execute the following code with 5 over here, you can see that the last value, right? The last value is outputted in white color, right? And I'm emphasizing this because later we're going to see things in yellow, things in orange and white, and I'm just going to explain a bit further. So I want you to be clear what's going on. So if I do display of 5, right, it returns, it prints out a 5, right, in orange color, right? That's important, orange color. And it also there's also a 5 in white color. White color is because display of 5 returns 5 itself. If I do display of hello, then this is going to return whatever it just displayed. So display does two things, right? One is it displays the thing in orange, and another is it returns the thing that is displayed. And the reason why this is important is because if I do something like display of 5, I'm going to see two 5s, right? And I'm going to see one white 5. So I see two orange 5 which is displayed, right? And one white 5 which is returned. So it's important to note that the display function not only displays something, it's not like print in Python, it not only displays something, but it also returns it. And this is important if you want to nest it like that. Otherwise, there's no way to display something a certain number of times without resulting to things like for loops. Okay, so this is just a short side note on um, the orange text versus the white text, and it's going to come in handy soon. Okay, so the first thing is how do we use the repeaters that are defined here, right? If we use the zero repeater is boring because the zero repeater just takes in a function and the input, and it doesn't apply the function to the input at all. It just returns the input itself, right? The one repeater would apply it one time, the two repeater apply it two times, and so on. So we might want to do something like this: two repeater, and it takes in a function that we want to repeat and input. So we might want to do something like that. So remember, this is the function currying means that we take in the display function, and this would return another function that takes in the input and supposedly displays it twice, right? So we want to do something like that, but right now we see that, okay, if I put in a semicolon, we see that display expects second argument to be a string, and the reason is that this function display I'm passing in here is not in the correct format, basically. So it turns out it's a little bit challenging in order to it'll take a while before we are able to even apply the two repeater function to a function that we want to repeat many times. And I'm going to spend around 10 minutes first motivating how we can use this. Okay, so the short answer, right, the short answer is that this will just be I, Y, and display of Y. This is the short answer. Okay, display of Y with this. This is the short answer of how we can use the function. Right, the function I pass in is not just display, but it's this entire highlighted region over here, which I'm going to call display wrapper. Okay, so if I pass in display, it doesn't work. I must pass in display wrapper in order for it to work. So I'm going to motivate how I define, how I arrived at this display wrapper. But before that, let's first start out simple and build up this definition of repeaters by ourselves. Okay, so I'm going to call my repeater functions by one letters, right? Z underscore R, and yeah, in order to avoid redefining these variables. Okay, so zero repeater takes in the function, takes an input, and applies it 0 times. So it just returns whatever the input is. So okay, then one repeater, I want to do this. So I want to take in function that is going to be repeated one time, the input, and it's going to apply f to the thing one time, right? And I want to do two repeater equals to, it takes in a function f, takes in the input x, and applies it twice. I want to do something like that, right? And likewise for 3. So it takes in a function, input x, and applies it 3 times. I want to do something like that. And if I do something like that, then I can do tree repeater, and I pass in the display function and the variable, the value of x, right, the input, and it works fine. Okay, if I do 2, then it will display it 2 times instead. If I do 2, then it will display it 2 times instead. Okay, so this is the simplest form of repeating a function, but this is very tedious, right? You see that then for each number of times I want to, for each time I increase one, I need to manually write out f one more time. So it'll be useful if I can basically replace, right, this double f of x, right? This is actually just a 2 repeater, right? So I can pass in 2 repeater f and x like this. So if I do this, then you see that the 3 repeater, it calls the 2 repeater, right? And the 2 repeater will repeat it twice, and likewise this is how I define recursively for 3 repeater. For 2 repeater, I can pass in 1 repeater, f, and x. Okay? And likewise for 0 repeater, I can do 0 repeater, f, x. Of course, 0 repeater, f, x, right, is pretty much redundant. This thing that I highlighted over here is pretty much just x. But I want to do it this so there's a repeated structure. You can see it's a very nice repeated structure over here. And yeah, so this is starting to look a little bit more like the function here, but we're still quite far away. Okay, so but anyway, this is how we can define our own repeater function. Okay, so if that's okay so far, then we're gonna pass in an additional parameter into the function here. So right now the issue is that if I had a 3 repeater, right, so given 2 repeater I can form 3 repeater, given 3 repeater I can form 4 repeater. But if I wanted to take 3 repeater, if I only had access to the 3 repeater over here, like this, right, and I wanted to create 2 repeater, it's currently impossible to do it, because basically every time I apply a function f, right, to something, every time I apply a function f, I've already done it. I cannot undo it in some sense, right? So that's why we're going to need to pass in a repeater here. So basically over here, one repeater will not only pass in the x into the function f, but it will also pass in a 0 repeater into the function f. And likewise, 2 repeater, right, it's not only going to pass in the f of x, right, into the function, it's also going to pass in 1 repeater into the function. And likewise, 3 repeater is not only going to pass in this f of x, right? It's also going to pass in 2 repeater into the function. And so now with this, right, we want to, now we have access to the repeaters. So the reason why I put in these repeaters once again is that so that 2 repeater has access to the previous repeater. Okay, 2 repeater has access to the previous repeater, then 1 repeater in this, by passing it into this function f. Okay, so this will be a critical point for how we implement decrement repeater later. We are trying to extract this repeater out of it using the function f, which we can control. Okay, so now let's try to use the repeaters we just defined. To use the repeaters we just defined, right? I need to call. I can have repeater, 2 repeater, and I need to pass in a function which I want to repeat many times. So let's try, right? I'm gonna pretend I want to pass in display and 5. If I try to do this right now, we see that we saw the error we saw just now, right? Which is that the display expects the second argument to be a string. Basically, what it's saying is that now display, right, is going to repeater, right, takes in a function f, which is what we pass in display as our function f, right? This f is the function that we want to repeat 2 times, right? So it takes in display and it takes in 5, right? The input x, and then it tries to call display on the 1 repeater, comma 1 repeater fx, right? So this 1 repeater fx is basically displaying x 1 time. But the problem right now is that the display function which we passed in does not eat 2 variables. The display function we passed in only eats 1 variable. So we need to pass in another function, right? And basically I'm going to define something called a display wrapper over here, which we see over here also. And this display wrapper is going to be able to eat pair, right? It's going to be able to eat a pair. And what does it eat? It eats a pair. The first element of the pair is the repeater that we passed in, okay? And for now, we're just gonna Okay, so it takes in a second parameter, right? I'm just gonna call it y. Okay, and for now I'm gonna ignore the counter repeater. Right? I'm gonna ignore the repeater that I passed in, right? Because remember, it's only useful if we want to do the decrement repeater. So for now, I'm gonna ignore it, and the y right over here is what I want to um, display. So I'm gonna call display of y. Okay. So now if I pass in display, remember it didn't work, so I must pass in display wrapper, and now we can see that if I call the tool repeater on display wrapper on the input 5, it displays it 2 times, right? Count the number of orange 5s there are. So if I call it 3, then of course it'll be 3 times instead. So now we have successfully implemented, we're very close right now. We see that it matches, right? We pass in 0 repeater, 1 repeater, 2 repeater into the function f, right? 0, 1, 2, but, right, the latter part over here doesn't match up yet, right? Currently we're just passing in the value, but over here they're passing in the function. And I think, right, so unlike the repeater that I pass in here, which is important, because if I don't pass in the repeater, I've lost information, right? I cannot decrement the repeater, right? More on that later. But if I do not pass in the repeater here, I cannot decrement the repeater. I cannot define a decrement repeater function, right? But unlike this parameter, right? I think this extra step over here is just to make your life a little bit harder, right? Because I do not see a motivation or practical reason for why you want to pass in a function that takes nothing and returns the value instead of just passing in the value itself. So for now, right, I see this as purely a attempt to make your life harder, but let's change it up so that we can match this definition, because the question, right, gave us this definition, so we got to work with it. So functionality wise, our definition of repeaters right now completely matches the question's definition of repeaters. But in order to match the exact form, right, um, we need to change our definition to match it up. So instead of just passing in, right, so the one repeater takes in a function f, right, which it wants to repeat 1 time, and the value, the input x, and it applies f on the function on 0 f of x, right, which is just x. So basically this is just x, this is as good as x. And it passes in the 0 repeater at the same time, but instead of just passing in the value x right now, basically I'm passing in the function that takes in nothing, right, and outputs that value. So this is as good as a function that takes in nothing and outputs x. Okay, and likewise, instead of passing in the f of x, right, instead of passing in f of x, I'm passing in a function that takes in nothing and returns f of x being just a value itself, right? And lastly, over here, a function that takes nothing and returns 2 repeater f of x, which is just f of x. Okay, so this is as good as saying f of x like that. Okay, not really, because now f takes in 2 parameters, but yeah. So now, yeah, ignore my previous sentence. That was technically wrong. But basically this 2 repeater f of x just applies f on x 2 times. Okay, so now if we change this up, then if we try to run it with our previous code, we see that instead of seeing 5 2 times, right, now we see this weird thing, right? And the answer is that now the y over here, remember whatever we pass in over here, right, we pass in display wrapper into f, right, and f gets called here. So this f over here, these 3 f's, right, this one, and this one, these 3 f's, they are display wrapper. Okay, realize that they are display wrapper and they stay display wrapper all the way, right? F never gets replaced, right? We're always passing in the same f. So at any level of at any level of repetition, right, the f stays the same. It's always display wrapper. Okay, but at each level of repetition, right, at each level of repetition, now instead of the y being the value that we want to display, now y is this entire thing, right? Previously we didn't have this void function over here. Sorry, previously we didn't have this function that takes in no parameters and outputs the value. Previously we just pass in the value like that. Now we pass in a function that takes in nothing and returns that value. So if this y is the function, then instead of calling display on the function, I need to call in display on the value that the function returns, which is just y, but you call it this time. So basically now y is a function instead of value. So when you call the function, and when you call the function is this function, and this function returns, it takes in nothing, right? Nothing in the brackets, it takes in nothing and returns the value. Okay, so now if I do this, then we see that we have successfully written a display wrapper that I can feed into the repeater function that would achieve the desired effect. Okay, and so now this is basically the definition over here, right? If I do this, comment out what I wrote, then you can see that the display wrapper that I just obtained, it works on the questions repeater also. In other words, my definition of repeaters has finally matched up with the questions definition of the repeaters. Okay, so you can see that my definition of repeaters is exact same as the questions definition of repeaters, except for the fact that I renamed the variables. Okay, so with that out of the way, I'm going to now get rid of my definition of repeaters, so we can purely focus on the function's definition of repeaters. Okay, so to integer, it basically counts a number of repeaters there are, right? But I won't focus too much on this because yeah, I won't focus too much on this. It's basically just adding 1 to 0 repeater number of times. Okay, so it's basically a function that adds 1 to 0 repeater number of times, and hence the result would just be repeater, right? The number of repeaters. So yeah, okay, so let's focus on this part. The decrement repeater part. So if I call 2 repeater on display wrapper, I get 5 times, right? 2 orange 5s. It displays 5 2 times. Now I want to implement decrement repeater such that I can pass in 3 repeater, and this must be effectively equal to saying 2 repeater. Okay, so if I comment this out, right, this currently right now the output here is 2 repeater. I want to implement decrement repeater such that decrement repeater of 3 repeater is the same as 2 repeater. Okay, so let's get rid of my answer over here. Okay, let me just show you that it works again. So if I do this, decrement repeater of 3 repeater display wrapper of 5, then we can see that it displays 5 2 times. Okay, so let me just comment out my definition, the answer here, so you can derive it from scratch. Okay, so decrement of 3 repeater, this decrement of 3 repeaters should return 2 repeater. Okay, and 2 repeater will then take in a display wrapper function, which it will repeat 2 times on the input 5. So how do we do this? Okay, for easier purposes, I'm going to rename this this function f g, and the result will be apparent quite soon because it'll be clearer which one is f, right? If I don't rename this to g, it may be a bit more confusing. So I'm renaming it to g so that it's easier to emphasize which function is which. Okay, so the idea over here is that the decrement repeater has access to the 3 repeater. Okay, and decrement repeater of 3 repeater, it takes in a function g, right? Display wrapper is g, and x is 5, and input x, which it will apply the function g on x, the n number of times. So over here I want to return 2 repeater, right? I want to return 2 repeater. Effectively over here, effectively I want to return 2 repeater on g on x. Okay, I want this to return 2 repeater g on x. But how do I do that? So I say must return 2 repeater g of x. And the key observation over here is to realize that I have access to these 3 pieces of information. Okay, g and x are things that I do not really want to change, right? I'm going to eventually, I'm going to, I do not want to change them because whatever the user pass in over here, in this case we pass in display wrapper, I cannot touch it as it goes down the levels of iteration. So, um, how can I extract 2 repeater out of 3 repeater, right? And the observation here is that 3 repeater, it takes in the function f and the input x, and it applies f on the 2 repeater, followed by this basically passing in, basically this is passing in the 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 the, the f of x, right? And the idea is that I have access to repeater over here, and repeater takes in a function. I'm going to leave it blank for now, right? And it takes in an input. In this case, the input is just x, right? Because whatever the function I pass in here, right, is going to be applied on the input, and the input doesn't change as we go down the levels of recursion, right? The 5 goes in here, right? 5 goes into this here, this x here, and 5 gets passed down into the lower levels as well. What I can control, right, x is something I do not want to change, because changing x will make me lose this information about this 5, and the lower levels will not be able to access this 5 anymore. But what I can control is the function that I pass in here, the f that I pass in here. Do note that the f over here that I pass in into the repeater function is not the function g. The g is the display wrapper. This function f that I pass into the repeater is this f over here, which I can control to extract out the 2 repeater. Okay, so basically, now I know this, whatever function I pass in here, right, I'm going to call it first. And first is a function, right? This f is first, right? This f is first, and this first function, I want to extract out the 2 repeater from it. So this first function, the function I pass into the 3 repeater, right? I'm calling it on 3 repeater. So the function I pass into the 3 repeater is this f over here. And this f, I'm using the f and passing into the function f a pair of items. So this first function, I'm calling it first for a reason. This first function takes in 2 parameters, previous repeater and y. I'm going to call it y, right? So this first function, this is f over here. It takes in a repeater and whatever this monstrous function that takes in nothing and returns 2 repeater f of x, right? So this first function takes in a pair of items. This is the pair, right? This is the pair. And basically, I want it to just extract out this 2 repeater over here. So in this case, I'll just return previous repeater. Okay, so this is the function we're passing in. You see that if I rename this first, okay, so if I rename this first to be, I'm gonna comment it out and rename it to be first of just simple enough, just a and b, and it just returns a. This first function, okay, I think this is even clearer, right? This first function is basically just taking in a pair of stuff and returning the first guy, right? This is how we define pairs in functional programming. So now I'm passing the first function, right, into the repeater. So this first goes into this f, and f is applied on a pair of the previous repeater, 2 repeater, and this, whatever this other part is. But we don't care about what this other thing is, right? The first function only extracts the first guy, which is this guy. So yeah, so this first function, when I pass into repeater, would extract out this repeater of first, right? This repeater of first thing would be the 2 repeater, would be the previous repeater. And I can actually show you that even more clearly if I just do first, if I just do true repeater of first. Okay, so I'm passing in, I'm doing true repeater of first of whatever x value, let's say 6. Okay, true repeater of first of 6 would be this one. If you recognize it, is the form of the 2 repeater. If I call 2 repeater of first of 6, then this will be the form of the 1 repeater. Okay, so by passing in, by cleverly choosing the function f that I pass into the repeater, you see that because the definition of 2 repeater involves passing in this 1 repeater, right? This 1 repeater is sitting there, right? Is chilling there, waiting for the function f, right, to extract it out. So that's the essence. So if I want to make a comparison with the display, right? In some sense, the display wrapper, in some sense, the display wrapper is doing the opposite of what the first function is doing. The first function is taking in the previous repeater, and b, right, whatever this monstrous thing is, and it's only repeating. The first function only returns me the previous repeater, whereas the display wrapper does the opposite. It takes in the repeater, but it doesn't care, right? The output, it doesn't care about the counter repeater. It forgets about its existence, basically, right? This display of y doesn't involve counter repeater. So this display wrapper is like the opposite of this first, right? Okay, so back to where we were. Decrement repeater or true repeater, display wrapper 5. Okay, so if I do this, you can see that we are almost there, right? Repeater first of x, right? This entire thing is, if I call this entire thing, it is this repeater first of x is the previous repeater, right? But right now we're returning the previous repeater, even though we've already passed in display wrapper of 5, right? So what this means is that essentially, with my current definition of decrement repeater applied on true repeater, applied on display wrapper, applied on 5, is equivalent to 2 repeater, literally equivalent. So if I print this, you see that this is the 2 repeater. If I print 2 repeater, you see that this is the 2 repeater. They're literally the same, right? But that's not what I want, right? If I define decrement repeater this way, then over here, because this entire thing is the 2 repeater function, literally, I need to pass in display wrapper again and 5 again, right? In order to display 5 2 times. So I want to avoid doing this, right? I already passed it in once over here. And where did I pass it in, right? You see over here I'm passing in twice, but I already passed it in once into G and X, right? So I don't want to repeat myself over here. So I need to change the definition of decrement repeater such that not only does it return me the second repeater when I pass in the third repeater, right? Not only is this thing, right? This thing is the repeater itself. The highlighted thing is the 2 repeater, right? The previous repeater. But I also want to apply the previous repeater on G and X. So I must pass in G and X like that. Okay. So if I do this, then this is the full definition of the decrement repeater function. And if I want, I can do it inline such that the first function is defined inline like that and doesn't rely on other definitions. So this is the full answer. And yeah, so if I now uncomment that thing, then we see that to int, if I convert the decrement repeater of true repeater to an integer, then I get 2. Okay, so this is how you arrive at the decrement repeater implementation.